Hello guys, today in this video we are going to be setting up and solving the double integral of x plus 2y over the region of integration where y ranges from 0 to 3 and x ranges from 0 to 2. So the first thing I always like to do is to draw the region of integration, and we can usually get that from the bounds. So stepping aside our xy plane, xy. So we have that y ranges from 0 to 3. So 0, let's say this is 3. And then x ranges from 0 to 2. So that's 2, which makes our region of integration this little rectangle. Now, for such a simple region, you really don't have to do this, but I still like to. For more complex regions where, let's say, y, the bounds for y is a function of x, it makes it easier if you draw it out. But for such a simple one, we really didn't have to. So now we just integrate. So first we are integrating with respect to y, which means we have to hold x as a constant. So it doesn't matter. Maybe x could be like 5 or something. It doesn't matter. So if x is a constant, that would make the antiderivative 0 to 2. If x was a constant and we integrate this would be xy, and then plus 2y. That's just the normal reverse power rule from Calc 1. That would be 2y squared over 2, and then the bounds start from 3 to 0. And notice you can just cancel this out. And when you plug in 0 for your lower bound for y, both of these terms are going to cancel out. Oh, I forgot to put the dx. Can't forget that. So when they cancel out, we will get the integral from 0 to 2, 3x plus, let's see, 3 squared. That's just 9 dx. Integrate this a second time. Antiderivative is 3x squared over 2 plus 9x. Just the standard reverse power rule again. From our bounds 2 to 0. Then when we plug in 0, it's going to cancel out. So we only have to focus on plugging in the 2. So that would make it 3 times 2 squared over 2. So that's just 3 times 2. That would be 6 plus 9 times 2, 18, which is 24. So yeah, that is the answer to this double integral. So the answer to the double integral is 24. But how can we connect this value to some sort of physical interpretation? Well, let's start by drawing our region of integration on the xy plane. In order to graph the 3D surface, we consider one variable of the function at a time. If we set y to 0, then we simply get f of xy equals x, which is just a line on the xz axis. Similarly, if we set x to 0, we get f of x equals 2y, which is just a steeper line on the yz axis. When we connect these two lines, we form a plane, which is our 3D function. Now the double integral gives us the volume of the shape that results from raising the region of integration to meet the plane.